Hi, everyone. Thank you for joining us today. We're excited to welcome you back to our Sync with an Expert series. I am Jennifer Steyer, the CEO of Safran Trusted 4D Inc., and we've got a great program planned for you today about NTP over Anycast. Our team of experts are ready to provide their insights on its capabilities for reliable and scalable time synchronization. We encourage you to engage and share your questions throughout the session. And with that, I will turn it over to Nadine, our moderator for today's event, to get us started.
Hi, everyone. I'm Nadine Flanagan, Inside Sales Manager here at Safran Trusted 4D. Today's session will be focused on NTP over Anycast. We're excited to revisit our NTP over Anycast capability, which simplifies the management of your high availability NTP networks. It allows even your simplest clients to take full advantage of the resilience built into your NTP networks and simplifies the configuration of the rest. To walk us through how NTP over Anycast can work for you, we'll hear from two of our Safran experts, Dave Sohn, Director of our Innovation and Research Unit, and Jared Scott, Test Engineer. After the presentation, we'll dive into a live Q&A segment. Many of you submitted questions in advance, and we thank you. We'll be addressing those, and you can also continue to submit questions at any time using the Questions tab at the bottom of your screen. If a question requires a more detailed response, we may follow up with you directly after the event. You'll also see a few quick polls pop up throughout the session to help us better understand your interests and tailor our answers during the Q&A. And if you get disconnected at any point, don't worry. Just use the same link that you used to join the webinar to reconnect. We're also recording today's event, and the on-demand version will be shared with all registrants available on our event page shortly after the session wraps up. Thanks again for being here. Now let's get started. I'll hand it over to Jared and Dave to introduce you to the magic of NTP over Anycast.
Thanks, Nadine. Welcome to another Sync with an Expert. This is our fourth edition. I'm happy to be back. This is my third take of this. And I'm happy to welcome Jared from the Test Engineering team. This is Jared's first time on Sync with an Expert. And happy to talk about NTP over Anycast. But I guess, Jared, a little bit we should start with is, it's NTP over Anycast. So I guess we should start a little bit of what is NTP and what does that look like in a standard configuration. Then we can talk about what NTP over Anycast is different with that. What does that add and kind of why would you do that?
Yep. Yeah. So starting from the basics, like NTP is a time service for delivering time over a network, essentially, and is typically implemented using a unicast communication protocol, which is the basic kind of configuration for doing NTP over any sort of basic network implementation. So that operates from a point-to-point sort of operation where you have a client and slave device that are able to communicate directly with each other. One thing to note about unicast implementation is that you might have, in much more complex network architectures, many different clients that are configured within a network, and quickly becomes very complex, and you're going through multiple hops, multiple channels to reach some sort of responding device, and control over all of the routing and the packets throughout the network is a little bit more complicated. So from there,
So regular NTP is this client-server protocol. It's not terribly complex. There's some complexity in there. But as your network gets bigger, obviously the complexity grows, and just the number of units grows. And exactly. As you know, it's kind of a tree structure, and so as that grows, the ones at the bottom of that, of that piece, which are the clients, the endpoints, that's what grows the most. And so in a complex network, you could have lots and lots of clients that you have to deal with. And not all those clients are the same. Some are much more simple. They don't have a lot of configuration, and some can handle some of the complexities in the network. But you may have a mix, and you may have a lot of them to deal with. And so what I've seen with these complex networks is managing those clients, managing the configuration on it, with all of those client systems, each one having to be administered. So that's one piece of it. And then the other side is that for those simple clients, that you're in this big network, you've set up your redundancy on your servers so that you can have backups in case there's a problem. But then your NTP client only can configure one server. And so what do? To me, that's
Yep.
why we did NTP over Anycast. So
Exactly.
what's different about NTP over Anycast? What is that?
Yep.
What does that bring?
Exactly. So, like you were saying, with all that complexity and things, Anycast really helps simplify it. And what happens is in an Anycast address configuration, where the client devices are actually, instead of requesting directly to the servers, they're going to request to what's known as an Anycast address or a virtual IP, a VIP sometimes referenced, and the devices will all seamlessly be sending packets to the same exact layer 3 address, which helps to simplify things from configuring many different servers or clients within devices. So you have one specific address that every client on your network is sending packets to. So it helps to really take away a lot of that hassle from complex networks where there's lots of different devices and traffic going on within a single network.
So this virtual IP address, this Anycast IP address, that's what I configure in all these clients.
Exactly. Yep.
Right? And so then the NTP over Anycast feature, that capability, means that the single IP address that I'm able to put across all those clients is actually going to multiple servers.
Yep.
And the redundancy that you've set up in your network distribution at the server level is still there.
Yep.
But you're allowing even your simplest clients to take advantage of that.
Exactly. Yep.
Okay.
And from the client's perspective, it's one device that it's requesting to, and it can switch to a different server without any worry of like some sort of brief transition and holdover or a momentary loss in sort of your NTP protocol itself, where you might see some sort of network time, like time jumps or some sort of skips. That this helps to really eliminate some of those worrisome things that could happen with switching between devices and things. So,
Oh, I love it.
Yeah.
I love it. Simplifying things, this kind of, magical feature that we have, but of course, something has to be happening behind the scenes. So how are we doing that? What do we do to make this happen?
Yep. And so this is done through route advertisement. So what happens is the NTP servers themselves are able to advertise to the layer 2 devices on a network routers to tell them to forward all that Anycast traffic to a specific device. And then and that's typically determined by the shortest pathway to that through a network architecture. And what will happen then is in the event of a network downage, GPS loss, or some sort of stratum transition with the NTP quality, we actually have logic in our system that tells the routing device or the layer 2 device to stop sending traffic directed to that Anycast address to the NTP server. And from there, that's where you get that seamless transition. So all of the routes are actually kept locally within the layer 2 device, and it's able to then, once it loses that one connection to the responding NTP server, switch over to the redundant other server that's on the network. And from the client side, this is behind the scenes, and it doesn't know that a server went down or anything, and you don't get any sort of loss for like a critical infrastructure or things like that. Yeah.
So when we talk about NTP over Anycast, from the client perspective, they don't have to do anything.
No. Yeah.
They don't do anything, right?
Exactly.
You have the virtual IP address, and all of that's managed within the network, right?
Exactly.
So how does this work with their system? I mean, it seems like somewhere in the network, somebody has to know where to go, right?
Yep. Yeah. So, and that's where the route advertisement kind of comes into play, where the devices are able to, on the layer 2 side, to communicate with each other and then pass off these static routes for relaying that specific traffic. So in the case of our products, the VersaSync 2400 systems, we're actually able to implement OSPF and BGP protocols for Anycast, which both share this kind of same attribute where we're advertising routes on how we can actually deliver the message to the server or the client specifically, based on when we're advertising and how that's happening.
So where is that communication? How is that communication happening? So it sounds like, okay, well, the communication between the client and the server is simple. It's the same mechanism that's used regardless.
Yep.
But something is happening somewhere to make this happen, right? I mean, it's not magic, right? It may seem like it, but it's not really magic. So what interaction is occurring? What are the servers talking to make this happen?
Yep. So on a Linux device like the 2400 or the VersaSync, they need exit routes in order to know how to send traffic and where to send traffic to. So they need the layer 3 destination IP and know which interface to send that traffic to. And we can communicate that through this route advertisement method specifically. So within the actual system itself, there's a packet exchange, a handshake between the VersaSync time server and the secure sync time server and the network router, where they actually are able to exchange those routes on the network for local IPs to those specific devices. So for the secure sync and VersaSync aspect, they're going to be advertising that Anycast address to the router, the layer 2 device, which will then handle the packet routing through the network. So when a client is like, hey, I want to know what time it is, and send something up to the your routing device will check its lookup table for how to actually deliver that packet and what the closest available time server is that's able to answer that message. And that message is dynamically controlled by the SecureSync 2400 devices, and then they're able to share that information between each other essentially.
Okay. So in here, the it's not just communication between the client and the server. It's the servers, the SecureSync 2400, the VersaSync, those systems talking to the routers in the network to do this.
Yep.
Okay. So then really the clients are going to this virtual IP address.
Yep.
That's what they're configured with. They make that query, right? It goes, using the regular networking techniques. It goes, okay, it's not on my subnet. Okay, where is this device, right?
Yep.
It goes to the router, and through the routing protocols, you said it was OSPF and BGP,
correct?
Right? Through those routing protocols, the routers know the information about how to get to that IP address.
Yes.
Okay, but where does that IP address take them?
So the IP address itself is handled directly locally within the time server device itself, and it's able to create the virtual interface within itself, and it's able to advertise that to the layer 2 device.
So really at the end, the routing information is, okay, I need to get that virtual IP address,
yep.
And the secure sync is saying, okay, I know how to get to that
yep.
IP address, send your traffic to me,
yep.
And it just then responds. So technically it has this virtual IP address internally,
exactly.
But it's really responding based on getting routed that packet.
Yep.
Okay. What happens if there's a problem in the network? If there's a problem in that server,
Yep. So there's within the time servers themselves, we implement logic within our to interact with our NTP implementation and the Anycast. So if we experience like GPS downage or any sort of failure on the system, like transitioning into free run, entering Stratum 16 and NTP, these logic triggers actually stop our internal advertisement for a specific server, telling the router that it's available to respond. And then from there, we're able to actually, really powerfully switch from, that specific device to another one without any like brief interruption, like entering free run, any sort of downage on your network for like any sort of critical infrastructure or things like that. So it's really powerful for helping to, seamlessly transition between responding devices really quickly.
So it's not just this, routing advertisements that actually make this work. So the routing advertisements are really just, okay, I can want to get from my client to one of these servers, okay, but there's some additional functionality that we've implemented to say that, okay, we're actually managing these routing advertisements to say, okay, if there's a problem on the server and it shouldn't be responding to an NTP because you said we lost GPS.
Yep.
We have some other sort of issue from our primary reference or secondary reference, and we've now gone into holdover. We're going to change our routing advertisement to say, okay, I'm no longer good, right? And so then what happens to that traffic then? It gets lost? Where does it go?
Nope. So once the server is no longer advertising to the router itself, then the router no longer sees that exit path to the versus sync or the secure sync or versus sync that's no longer advertising that it's capable of doing that, and so then that traffic just gets diverted to the next nearest device that is capable of responding that's still configured within the network.
So in the routing protocol, we just say no longer route to me. I can no longer reach this. I'm no longer good for this IP address, which has the effect of basically sending that route to another device.
Yep.
Right. And so now this new device is now going to respond to that client's request. So this new server has now stepped into that virtual IP address to respond to that client.
Exactly. Yep.
Okay. Now you said, so we talked about this is using kind of traditional routing protocols to achieve this.
Yep.
What's kind of the difference between those two routing protocols? Is there a reason that a customer would be set up with one or the other?
Yep. So the two routing protocols supported by our products are the OSPF and BGP. So we'll start with OSPF first and kind of look at that. It's the simplest of the two protocols, so we can start there. It's called OSPF, standing for Open Shortest for Pathway First, and operates more or less using a flat network structure, and routes kind of generally are prioritized by the least number of hops needed to reach a specific destination. So it's very easily configurable, but with that easy configurability, you lose some of that kind of control over specific routes that are advertised within your area or the network segmentation that's operating using that specific protocol. And then the number of hops increases over additional areas as you kind of increase that complexity. So scalability and configurability, you kind of lose a little bit there, but you trade that off for easy configurability, and within a smaller network segmentation, it works very quickly and very fast, so you're able to update those routes almost instantaneously. And then we can see BGP on the alternative, which stands for Border Gateway Protocol, which is a little different. So it operates more in a hierarchical network structure, and typically is implemented in conjunction with OSPF as well on the further down end. So BGP itself is able to operate inter areas, so between OSPF areas. And it can combine all of these local network segmentations and do the same Anycast protocol in conjunction as well. But with BGP, you're able to have a lot more configurability, so you can assign merit-based aspects to specific routes, which gives them priority over other ones, rather than just simply, what's the closest device to my thing. So you can actually see like network latencies, and there's different aspects that you can control as well there. And you're also able to have more control over what routes are advertised. And because of all this flexibility, it's easily scalable in large networks and more complex networks. And so when you're adding on additional routing devices, clients, servers, whatever is operating your network, it's easily scalable, and you can it doesn't require much additional configuration where you're losing some of that speed due to multiple hop increases and things like that.
Okay, so OSPF a little bit simpler to set up, a little simpler on the protocol side. doesn't have necessarily the flexibility, the kind of granular control on what you can do with it.
Yep.
BGP, more complex, but with that complexity, you can have more control over where things are going, and can designate, I think you said different areas with kind of some different rules based on that, and that they can mix. So technically, a user's network could really manage with both of these.
Exactly.
So now, one of the things that I understand with this is that you have clients that of course are spread out over your network. They're finding this virtual IP address, and they're going to the routers and requesting that. They may not go to the same server in the end, though, right? You may have one IP address that's configured now across all your clients, which is great because it eases the configuration for all those many clients that you have. But they may not go to the same server. So they go to, you see one IP address, but they're not actually going to the same server.
Yeah.
Right?
Exactly.
Huh. That's interesting.
Yep. So you can have multiple devices throughout your network, and based on all of their allocations and where they are in the different network segmentations, there's going to be different responding servers that are either closer or further away. So, not everyone's going to be requesting one specific server. It's going to be mostly divided amongst it.
Okay. Well, I mean, this it sounds, SPF said, simple, BGP a little bit more complex. It sounds like it could be pretty complex to set up and configure, right? I mean, people used to just doing, on the servers, you set up all the regular server things on the 2400, the secure sync and your NTP. On the client side, you set an IP address. Now there's an additional, layer of complexity, right, in configuration. How do you, how we tried to simplify that in the system? How do you go through and configure these things?
Yep. So within the SecureSync 2400 and VersaSync devices, we have a GUI interface that allows the users to configure the Anycast within the device using 3 simple kind of configuration windows. And we allow users to configure specifically the Anycast address to whatever designated layer 3 IP address that the user wants to use to request time to. And that's supported by both IPv4 and IPv6 protocols. And within that same configuration window, we also have a specific option for diverting traffic out of a specific Anycast port, so the one that you're using to communicate with the router itself.
Okay.
And this is only for a very specific use case where you are not actually going to be advertising static routes across your network, so you don't want to share any IP information. So it helps keep some of those routes ambiguous. So for security reasons, and any sort of person that might be listening in or be able to figure out those routes that are being exchanged. You can use this setting instead, which will more generally handle all the exit traffic. And then we allow the user to configure each of the OSPF and BGP Anycast services individually. So we give the user the ability to configure the area that the SecureSync 2400 is going to be operating in within their network.
Okay.
So that area itself will be able to advertise with a different area or the other routing devices that are in the same network area. And that's how we're able to do that exchange and advertisement of routes within that specific device. And then on the BGP side, which is a lot more involved specifically, the network segmentation reference is called an ASN, which is an autonomous system number. And essentially that's just a way of organizing your specific network segments in a more complex network structure, essentially. And we give users the ability to configure the SecureSync's autonomous system number, so the designator that's assigned to where the SecureSync is operating, as well as then configuring what your neighbor's autonomous system number is, and the neighbor information such as the IP address and the autonomous system number are both designated for the routing device that these packet exchange will occur to advertise the routes between. So it's the same thing, generally speaking, as kind of what the OSPF areas are doing, but it's a little more configurable based on the hierarchical structure of BGP itself.
Okay, so now these are configuration settings that obviously make sense with those protocols. So
Yes.
meaning you're doing OSPF, you're setting up this area address,
Yep.
and that's typical what anyone, your network administrator, the network engineer is doing on the routers. That same information that you would be doing in the router setup,
Yep.
that's the kind of thing that you would set up
Exactly.
in the 2400 versus 6. So those kinds
Yep.
of things. And so OSPF a little bit simpler, BGP a little bit more complex. But I have to imagine that in terms of the protocol, there's actually more complexity beyond that.
Yep.
Okay, so that seems like those are sort of simple setups, right? But what have we provided to allow if maybe this user's network is maybe a little bit more complex. They've done some special things
Yep.
to tune the routing this way or that. How would they manage that with kind of just the UI side? I mean, I saw it in the OSPF. If you look at that configuration, there's like one thing to set. I assume that there's more that happens in the protocol than just that one setting. I mean, it sounds like that would be very simple, but it just doesn't seem like that's really the case, right?
Yep.
And the same thing with BGP. We talked about it, and you talked about it. Much more kind of complex capabilities that are in there. Doesn't look like we expose all that in the kind of the regular UI. How would a user interact with a network that has some of that complexity built into it?
Yeah. So we actually give the users the option to enable expert mode, which gives direct access to the configuration files for the actual service itself that we have running on this 2400 that operates NTP Anycast. So we give a lot more of that complexity and specific configuration based on network needs, depending on if this is already a pre-existing BGP or OSPF setup that has specific control over routes that are advertised or assigning specific network segmentation to specific devices, and it allows sort of that more close control over these protocols specifically to fit the needs of whatever your network is that this is being implemented into.
All right, so if I think about that, in myself is, okay, well, we provide the basic setup that you need, the common settings that you would do in a typical setup, whether you're doing OSPF, you're doing BGP, but then with this expert mode, we provide access to basically everything that the system can do, the packages that we're using to support this, and you can configure that specifically to add in the nuances of how they've configured their networks.
Exactly.
Okay, well, so it could get complicated with that. Right? So what's with how would you see this in operation? How would you know that this is operating how you want? And to me, this sounds perfectly up your alley. Being in the test group, we put these features out, we develop them, and then we hand them to you and say, hey, make sure it's working. So what are you using to test this, to see how this is working, that a customer who's implementing this for the first time, or they have it running and they're trying to figure out what's going on, what do they do?
So like you mentioned, this isn't something that's extremely apparent or obvious when it's working or not. So it does require looking a little bit into some of the back end of the device, or looking at some of the CLI interface and some of the actual Linux handlers within the system to confirm that things are working properly.
Okay.
So the first step that is what you want to do when you configure Anycast is first check that the loopback interface is there. This is a very simple thing, but it's critical for everything else in this process to work. And this is where the secure sync will create that layer 3 interface within the IP address table of the actual device itself, so that it can do the advertisements from there.
So what you're saying is, first step, we talked about is like, you're going to have this virtual IP address.
Yeah.
So the first step of troubleshooting is, did the device create that virtual IP address on the system? Okay, well that seems straightforward, right?
Yep.
You want to make sure that basic thing. Okay, so now this IP address, you see it set.
Yep.
How can I know that it's connecting, that it, because we've got both the regular NTP protocol that's occurring.
Yep.
And on top of that, we also have these routing protocols that are occurring. So.
Yep, and that's once you enable the actual device, you want to be monitoring that sort of exchange of packets. So, in this instance, you'd like to use some sort of packet capture tool, which the secure sync and VersaSync devices happen to have TCP dump, which we can use to perform a packet capture locally to confirm that, or you can do it on the layer 2 router side, which a lot of those devices will typically implement that. But we're able to actually confirm that packet exchange is happening. You can actually even see the routes being exchanged between the two devices within the packets, and confirm that you're able to get that handshake and that the devices are able to establish the protocols initially. Yeah.
Okay.
And from there, we want to make sure that those packets during the exchange are then set within the routing table of the secure sync device. So the secure sync needs to know how to send traffic from that specific loopback interface that's local to the device. And we want to look in the main routing tables, which will contain the zebra metric routes, which are the ones that are set through the Anycast protocol itself. And that's how you can really confirm that the full exchange is happening, and then you see those populated routes to tell the secure sync, this is how I can send from the Anycast address specifically.
Okay, and then I assume that the system administrator, the network engineer, can also look on the router side and say, okay, I'm in this this router, and I can look at my routing table in there, look at the OSPF area, see that I see the router advertisements coming from the 2400 or the VersaSync in the BGP. You can see it's registered in the area. Right. Yep. Now, what is we talk about how this makes it simpler from the client perspective. Is there something from the client that you see? So what happens on the client? We go through and you're communicating to a server, you're making those requests, you're getting the time, and that server loses its reference, right?
Sure.
And now it's switched. It's now going to be getting its time from someone else.
Yep.
Because that 2400 or the VersaSync is now telling the network, hey, don't send those packets to me anymore, right? I'm taking myself out of the route. It's going to get routed somewhere else. What does that do to the client? How do you see that on the client side?
Yeah, so in Anycast scenario, you shouldn't see any sort of change within the client side, because as far as the client knows, it's still sending its packets to the same destination or that Anycast IP.
So it should be basically seamless to the client.
Yeah.
Oh, see, I love that. Come on.
Makes it all simple. Yeah.
It's magic that we're creating in over NTP with this NTP over Anycast.
Mm-hmm.
All right, so you went through finding out that hey, these router advertisements, the routing tables are set up. I guess what I'd say is there's more questions on that, more other troubleshooting techniques. Why not give a plug for our application engineering team? They're great. You can reach out and we can go through some of those more advanced techniques that Jared has mastered back in in test engineering to figure out what's going on with this. And I see we have some questions coming in, so I'm going to hand it back to Nadine to help us go through with those.
Thank you, Dave and Jared, for that excellent presentation on NTP over Anycast and how this can work best for our customers. Now we'll begin our live Q&A session, your chance to ask our experts any question about NTP over Anycast. Once again, I'll hand things back to Dave and Jared to get us started.
All right, thank you, Nadine.
Well, it looks like we have a bunch of questions that have come in. Jerry, ready? Let's go through them.
Yeah.
Oh, this is an exciting part. I love the live question board. Okay, so first one I see. What are the disadvantages of using NTP over Anycast?
Sure. Yeah, so I guess the main disadvantage of using NTP Anycast is the additional equipment, the layer 3 router, packet router that you would need in order to configure and set up the actual protocol to work properly versus like a unicast configuration where you just have client to server. A lot of that can be deployed in a much simpler network environment. So it adds another layer of complexity, at least for the equipment required to perform the actual protocol.
Right, so there's a balance there, right? So you have the advantage of reducing some of the complexity in the, let's say, the NTP portion of this on the clients, et cetera. But there's complexity because now you're connecting this into your routing network.
Exactly.
I'll add another one. So for those clients that are more capable, they're no longer doing the NTP selection themselves, right? So
Yep.
you're taking that out of the hands of the client and putting it to the server. Now, I'd say it's a little bit of advantage because now all of those clients will be doing the same thing. You can know what's going to be happening because now the NTP servers at the front end are managing that piece of it. So managing that resiliency there. Yeah. All right, let's see. Another one. The Anycast IP address is enabled based on the NTP service availability, or is it permanent? So is the, let's take this kind of two parts. So when they set the NTP Anycast, is that permanent there? And then also maybe we talk a little bit about how we turn on and off that or enable and disable an individual Anycast from an individual server.
Sure. Yeah, and so once you actually configure the Anycast IP address, it is enabled in the actual IP lookup table. So for the local addresses that are contained within the actual secure sync, so that will be created within the loopback interface.
Okay.
The main difference being is that even if NTP service is not available or you're not advertising that specific route, there won't be an exit route for that specific interface. So while the interface will be created once Anycast is enabled, it's not necessarily going to be advertised across your network to perform NTP communication and traffic.
But it's static in the sense that, okay, once they configure it, if we're advertising or we take down the service because there's a problem on our reference or the NTP connection for what we're doing on that server, we're no longer advertising for that server and it's going over to another one of the servers that's providing NTP Anycast.
Yep.
When our service comes back up, it's going to be the same Anycast IP address that's being advertised.
Exactly.
That was configured before.
Yep.
All right. This is an interesting one. Is this the same as PTP multicast? I mean, I would say from the first part, of course, it's not because this is NTP. PTP multicast works a little bit differently. I mean, one right in the name, it's a multicast protocol, and so requires multicast traffic on your network, registering with the multicast domains.
Yep.
And a little bit more complexity, which sometimes I know customers or users don't like to do, is if you need to traverse subnets, you have to enable multicast routing in your routers.
Exactly.
And some infrastructure don't like doing that. What else is the kind of the differences between PTP multicast and NTP Anycast?
So I mean, at its core, Anycast is still going to be doing unicast, so that kind of that point-to-point flow. And the main difference being you're advertising and sharing those local addresses across your network. So there's still some differences in terms of exactly like the handshake that's being made between the router and the time server that will be sending and advertising. So main difference there just being, that sort of communication exchange between them. Multicast is more of a one-to-many. So you can have many different devices joining the same multicast group and responding. So the direction of the packet travel is a little bit different, and Anycast is able to select the single device to receive it using the shortest pathway to the responding server, essentially.
Right, and actually, some other slight differences, right? So multicast, so in PTP multicast, you have your PTP transmitters that are are active or passive based on the best master clock algorithm. And so they actually have to transition themselves within the multicast domain, right? And there's only ever one that is actually active through the entire multicast domain.
Exactly.
So regardless of how far away a client is from a receiver from that transmitter, it's always going to be responding from that one active multicast transmitter. Whereas in NTP over Anycast, the difference is that depending on where you are in your routed network, all of the servers that are available are always available. And so you may actually have clients that are on different parts of the network that actually reach a different Anycast server because that's the closest one in terms of the routing protocol that it can get to. Right? Yeah. Okay. So this one's a little bit longer. Curious if you're running a routing daemon on the timing appliance as part of this product, or if we're using a route reflector monitor. And then the second part of this, and is the on-device behavior for the enabling and disabling of the Anycast IP depending on service health.
Yep. Yeah, so our device uses a routing daemon within the Linux that's running on the system. And essentially, that controls all of the advertisements and the routing protocol itself. This allows us to have less additional equipment that's needed to perform Anycast. So having any sort of external monitor or route reflector to monitor our device specifically. So it helps to just reduce some of that additional infrastructure. And the daemon interacts with the NTP service itself, and there are specific conditions when losing a reference or entering holdover free run, where that address will stop being advertised across your network, and you will no longer be a capable server of responding in that sort of scenario. So that's where the up down happens, specifically dependent on the NTP service health and the system health of the 2400.
Right. So we are running kind of a daemon on the server in order to manage the routing protocols. We're not actually a router, so we're not doing full routing on there. It's just for managing getting from our normal interface into the Anycast address and advertising that out. And then the piece on the service, right? It's the system is looking at various elements for when NTP should be served from that device, including, the status of the NTP service itself, but then also things you were mentioning, like the reference, reference availability. It would also include some of the other things that we do within secure syncs, like our IDM detection, so if there, let's say GNSS was your primary reference and you're running IDM, there's some problem on that's no longer valid. That also filters into the decision of whether the NTP service is available and whether the Anycast is being advertised or not.
Yeah.
Right. Okay. What is the absolute time accuracy with NTP sync, and what is the NTP time base?
So the time accuracy would depend on a couple.
The best answer that we always give is, it depends, right?
Hard.
So what are the various things that it kind of depends on?
Yep. So the number of hops in between your responding server and your client device, your reference quality. So, whether you're using GNSS and have clear skies and, perfect signal versus, in a more convoluted area like an urban environment or things where there might be, reflections and different receivers that could potentially be interfering. And then that can affect the quality. Typically, from like a unicast point-to-point perfect scenario type scenario with NTP, you want to be looking for sub millisecond accuracy.
Yeah.
Typically, that can be achievable if it's a very, very simple configuration, but introducing multiple hops and additional network runs and cables in between can all contribute to a little bit of reduced accuracy, and so it's hard to quantify an exact number.
Right.
Yeah.
Well, I mean, so NTP can operate down into the microsecond, single digit microsecond, even a little bit less, depending on some of that. The NTP time base is really based on whatever you are selecting, right? So if you have your references GNSS and it's available, well, that will be the time base, but it's really dependent on what the reference feeding into the secure city is, and that's what's going to decide that.
Yeah, you could have like a higher quality reference, like using like a local, advanced oscillator or things providing like PPS 10 megahertz for synchronization,
or going back to one of our previous Sync with an Expert, could be White Rabbit through the Rocks option card, right? So, all right. So will materials and slides be available after the presentation? So this webinar is not only just live, it'll be recorded, so you can come back to this and look at it again. And then we have a number of resources on our site around NTP over Anycast and the devices. What else, Jared?
There's not necessarily a slide deck, but all this stuff will be available online. You can access a recorded version of this post presentation if you want to look back on some of the troubleshooting techniques or things like that. But we also have technical application notes available on our website, or you can reach out to anyone on our service team and they'll be able to help provide you with those materials to reference if you need additional support, either troubleshooting or configuring or deploying in any sort of scenario.
Yeah, I'll also give a shout out to our online user manual that you can go to and look at for some stuff.
Yep.
Yeah. Here's one on troubleshooting. We just talked about it. So we have BGP Anycast enabled, but there's no testing or troubleshooting guide available. It's available only for OSPF in the Safran portal. What can we just check the daemon status using system control? And when are we introducing the show BGP? Wow. Or a pairing status command. So this gets into like a little bit of how we choose the kind of command line options that we have available to the user. We talked a little bit about your experience in doing troubleshooting. So this one's asking specifically about BGP. You want to talk a little bit about what we have available on the system to do that?
Yeah, both methods are going to be very similar in terms of how you troubleshoot them. BGP versus OSPF.
Yeah.
On the device, currently the best method for analyzing those services, ensuring that they're working properly, is to use that system CTL command. They'll give you a status snapshot, whether the service is running properly, and if there's any sort of error, like syntax error if you're using expert mode, or something's not working properly with executing it. And then there's an additional command which is using the journal CTL command within the Linux system, and that will show you a much more in-depth breakdown of all of the specific status notifications, or sort of and mark it down in like a log form to kind of help with some of that. Additional troubleshooting would be was mentioned in the video, such as ensuring that the loopback connection is established. You can use any sort of packet monitoring, packet capture tool to make sure that the BGP or OSPF service are doing the handshake properly and exchanging the routes with the router, because you can actually follow those packets through the protocol and make sure that they're being exchanged properly. And then you can use a combination of any one of those tools to kind of help from the secure sync side. Otherwise, using the router will give you a lot more in-depth.
That's right.
Analysis.
So another part of this is actually going on the router that we're advertising to.
Exactly.
And then looking on there for some of these commands. to see, right? So actually, that was a great one, especially if you're using expert mode.
Yeah.
Is looking at, when you try and start the service, looking at system control, making sure that, okay, the system came up properly, there were no syntax errors or errors in the data, in the configuration that is preventing, service startup.
Yep.
So for site timing and relative timing between remote sites, is there any easy method to utilize stable frequency sources such as masers or cesiums to increase the time-based stability? Is there some documentation we have to do that within the Anycast protocol? So I'll start a little bit on this. So this would, this is a little bit of independent of NTP over Anycast,
Correct.
right? So one of the values of NTP over Anycast is it's really anything that we would be, from the system perspective, anything that we can do with the regular NTP, this just allows that to operate over NTP Anycast. So this is really more of a question of how do our devices connect to a maser or a cesium?
Yep.
And so that would be using, either the frequency input or a 1 PPS or pulse per second input that might be coming from that maser or cesium. And that could act as either a primary reference into that or as potentially a backup to the GNSS or something. And this can be where you have, multiple systems where some may have backups and some may not. And depending on looking at your overall architecture, what your kind of your failover schemes look like,
Exactly.
right? Yeah. Okay. So with Anycast, are we speaking about utilizing multiple timing NTP broadcasts above and beyond the current delay and averaging to an upper limit, say, N of timing sources? So I think this is asking, like, is it mixing? So that this sounds more like on the client side, are they seeing multiple sources? And the answer to that is no, right? They're just talking to one, right? But maybe talk a little bit about what this means about how many of these would you want to set up in a network? Like if you're doing an Anycast setup, is it, obviously it's not just one because that doesn't work. Is it 2? Is it 3? Is there an upper limit? Is there, what kind of things do you think about?
Yeah. So within, a local network segmentation, it's probably best to assign at least one server per segmentation if possible. And then that will provide you with a local reference or something that's close by that can respond to your client devices, and then also allows for the redundancy and that seamless transition between the active server to a backup one, which might be another network hop away, et cetera. So it's a good idea to at least have, one per specific segmentation to ensure that sort of redundancy.
Yeah. So thinking about, both resilience in the reach of your network and the kind of failure modes these can have, right? So if it's, you might want to have, a local one to to a site that you are. And then let's say you have a connection to another site, another geographic region, that would be potentially another one that you would want. Now with the Anycast, one of the benefits we talked about, right, is if you're on that local site, you're going to be, based on the routing protocols and how they work, you'll almost certainly be talking to the NTP server that's local, right?
Exactly.
But something goes wrong with that NTP server, our service pulls it off of the Anycast. You'll be going over to that redundant system that might be geographically diverse, or another one on your site. That can also protect, like if there was a GNS event or something like that. It also allows that geographic diversity.
Where if like your local site loses GNSS, all the servers go down, and then you have that backup site, which might be in a different location, could ensure that.
Right. But in terms of you're still doing a single client server communication for NTP though. So this is a good one on a little bit on configuration, how on the feature. I'm advertising 2 Anycast IPs from a single device. Are there any limitations on the number of IPs that can be advertised from a single device?
Yep. So not specifically. You can actually configure multiple Anycast virtual addresses using expert mode specifically.
Mhm.
Our standard configuration only allows one layer 3 address to be assigned, but you can configure multiple, or if you're using IPv4 versus IPv6, you can use those. So there isn't necessarily per se a limitation, but the more you have, the more routes will be exchanged, and it can get.
I will say that my answer to some of these is like the limitation is not on the system side; it's really on what's practical when you're designing this, right? You could have a lot, but does that make sense for your setup?
Yep.
Oh, it's nice. Is the redundancy seamless? Does it require any interaction from the user, or is it kind of automatically done?
So, and this is that kind of magic of Anycast that we were talking about.
Magic.
Oh yeah,
I love it.
It's all seamless. It's in the back, so the user does not need to interact specifically with the devices to ensure this transition between your active sources. The router or the packet forwarding device that's capable with Anycast will handle all of the transitions between active and inactive servers essentially.
Now, so I take it. I'm gonna ask a few leading questions here.
Sure.
Why not? How long does it take to switch over from, let's say we take off the Anycast service? How long does it take to switch over from one to another?
So it depends on the size of the network, the number of hops.
Depends.
The number of hops, but typically in a smaller scale, it should be almost instantaneous.
Okay.
It can be within like a second or two to actually have that switch between the routes there.
So there may be a slight delay, and I know some of that's configurable based on your advertisement timing and also on the router side.
Yep.
So it's a little bit in how they set up their BGP and OSPF.
Yep.
In their network, but that's regular configuration even for loss of a router.
Yep.
From the NTP perspective, what does that mean? So if it occurred during a request where you had something routed, you might get a packet drop or where the NTP client would see, oh, I didn't get a response, and then I would send out my next one, and then it would get routed to another one and get that next response.
And ideally, if you're losing one or so, the quality of your NTP would degrade in the monitoring for when it's pulling, but it's very instantaneous. So it would ideally only be, like one request or so. Yep.
Okay. I think maybe time for one more question. Okay, so this means Anycast can only work on a layer 3 network using OSPF or BGP. A normal layer 2 switch will not work.
So if it's layer 2 only, I guess we'll start. Anycast is a layer 3 protocol. So the device that it's operating through needs to support layer 3 routing in some capacity. So there are switches that do support layer 3 routing and also control the layer 2 side of things. So that is one limitation where the switch you're going through needs to be compatible with that.
Right. So your network infrastructure already has to be doing these routing protocols. Typically, you're not setting your routing protocols based on NTP Anycast. You're already using these routing protocols, and the servers are going in and connecting to that existing infrastructure.
You're leveraging what's already there.
Yeah, exactly.
Mm-hmm.
All right. So I think it's time to wrap up. This was great. Thank you, Jared, for joining us. I hope you enjoyed it.
Of course.
And I want to thank everybody who was listening to us again. I want to say, if you have more questions, please reach out to either the sales team or the technical team on the service side. We have a great applications engineering team who can help with your pre-sales questions and as well getting this set up and running.
Thank you again for joining us today. As we close, you'll see one final poll on your screen asking if you'd like a member of our team to reach out and help determine whether NTP over Anycast or another Safran solution is the best fit for your needs. You'll also find links to share your feedback on the webinar or get in touch with us directly. And now to wrap it up, I'll hand it back over to Jennifer.
Thank you for attending today's Sync with an Expert event. I hope you learned a little more about our products and features. And if you have further questions or feedback, please don't hesitate to reach out to us. We appreciate your continued engagement with us. And as the year winds down, I would like to personally wish you a happy, healthy, and safe holiday season. I look forward to working with you in 2026.